is 4000.
You can also use this type
you can
PLC
control very large scale of the sensor inputs and
TA
output
portal.
actuators.
S7400.
The CPU is available from
PLC is very common
PLC and
480.
mostly every complex
And
machine
if you
has
want
this type
to
of
connect
PLC.
your machine with
because
DCS
it's a
system,
modular
so you
type
have to
PLC
use this type of
and
the
has
PLC.
a very
Because this
capacity
type of the
digital
digital
and analog
S7400
is has a
input is
DCS
very high. The digital
connected
input output
built-in
capacity is
system.
16,000.
You can easily connect your
384.
PLC with DCS system.
And
The
capacity
programming
of the
software
analog
schematic
input
manager is
output
the old
is
software
4000.
and nowadays
TA
value
portal is very
you
common
can
software
control
of
very
the
large
PLC.
scale of the
You can
sensor
also
inputs
use
and
it
output
for
actuators.
controlling and programming the
CPU is
S7400
available
PLC.
from 400 to 12 to
S71200.
And if you
S71200
want
PLC
to
is
connect
widely
your
used
machine
PLC
with
in
DCS
small
system,
application
so you have
with
to use
modular
this
based
type of the
IOs.
PLC.
You
Because
can
this
extend
type of the
11
PLC
IOs module
S740 is
depend
has a
upon CPU model
DCS
with 712
connected
PLC.
in built-in
You
system.
can connect
So you can
your
easily connect
any
your
input
PLC
module,
with
output
DCS
module, motion
system.
controller with this PLC.
The programming software is
according to
schematic
your
manager is
project
the
and
old
logics.
software and nowadays
The
TA
software
portal is
for
very
this
common
PLC is
software
available.
of the Siemens
Schematic
PLC.
manager.
You can also
Schematic
use
manager is the
it
old
for
software
controlling and
and
programming
TA
the
portal is the new
S740
software.
PLC.
You can also use schematic manager
S71200
and TA portal. S71200 PLC is widely used PLC in small application with modular based IOs. You can extend
PLC
11
is
IOs
very
module
advanced
depend
PLC
upon
of
CPU
the
model
Siemens
with
brand.
712 PLC.
It is a very
You
user
can
friendly
connect
PLC.
You
can see
input
in
module,
the picture,
output module,
it is
motion
a LCD
controller
in
with
front
this
of the
PLC
CPU.
according your
By
project
this
and logics.
LCD you can see the
The software for this
problem in the
PLC is available
CPU
schematic
and
manager.
PLC.
Schematic
And
manager
you
is
can
the
also
old
check the
software
error of the any
and
type
TA
of the
portal is the
communication
new
and
software.
any
You
type of the
can also
input
use
output error.
schematic
You can
manager
see the
and TA portal software for
in
this
this
PLC.
LCD. The software of this PLC is a TA portal.
S71500
and
PLC
you can
is
very
the
advanced
PLC
PLC
you
of
can
the
program it
Siemens
by TA
brand.
portal.
It is a very user friendly PLC. You can
Now
see
last topic
in
of
the
this
picture,
lecture is the hardware of
it
the
is the
Siemens
LCD
PLC.
in front of the CPU.
You can see first
By
one is the
this
power
LCD
supply.
you can see the
PS
any
is the
problem in
power
the
supply by
CPU
this
and
module.
PLC.
The supply
You
of the
can
voltage
also
of
check the
24
error
is
of
given
the
to
any
the
type
all
of the
the
communication
modules
and any type of the
And next one is the
input output
CPU.
error. You can see the
This is the CPU of the PLC
in this LCD.
and next one is the IM is the interface
The software
module.
of the this PLC is
and
a TA
next
portal.
one is the
And
digital
you can
input
connect the software
and
and you
next
can
one the
program
DO
it
is the
by
digital
TA
output.
portal.
And next one is the AI is the analog input. No last
And
topic of this lecture is the hardware of the
AO
Siemens
is
PLC.
Analog
You
output.
can see first one is the
And
power
this way
supply.
you can connect
Yes,
your
is
input
the
output module
power supply
digital
by
analog
this
according your
module
project
the
and
supply
your
of the voltage
design.
of 24 is given to the
Now
all
last
the
two,
modules
FM
and
and
CP.
FM
And
is
next
the
one is the CPU.
closed loop control module.
This is the
And
CPU
last
of
one
the
is the
PLC.
Profibus.
CP
And
is the
next one is
Profibus
the IM
industrial
is the
internet
interface module.
communication system.
And
if
next
you
one
want
is
to
the
control
digital
communicate
input,
this
the
PLC
TI.
to other Profibus
And next one is
is
the
the
DO is the
communication
digital
system will
output.
be used by this module.
And next one is the AI is the analog input and AO is the analog output. And this way you can connect your input output module digital analog according your
Hello
project
friends,
and your
today our
design.
topic is S7300
Now last
PLC
two,
hardware
FM
and how to
CP.
add this
FM
hardware
is
in
the
schematic
closed
manager
loop control
software.
module.
And you
And
can
last
see
one is
in
the
the screen,
Profibus. CP
this
is
is
the
a
Profibus industrial internet
S7300 PLC hardware.
communication system.
First one is
if
the
you want to control
PS,
communicate
PSP is the
this
power
PLC to
supply.
other Profibus
And second one is the
communication
CPU.
system will be used by
And
this
third
module.
one is the IM, is the interface module. If you want to interface your PLC to other PLC,
When you
have
get
to
your
use
next
this
big
interface
idea,
module.
say
And
Sparkly Ketchup.
this one is the
Grammarly's
DI,
total
it is the
suggestions can
digital
help pitch it
input
with
module.
confidence to get your
And
team on
this
board.
one is
see her
the digital
email?
output
Already
module,
calling vendors.
DO,
Oh no, a
and
project
it's the
hiccup.
You need
and
to
the
squeeze
AI
the bottom.
analog input module.
Good idea. With a more
And
diplomatic
second last
approach,
is the
your
AO,
request
is
will
the
get a
analog
better
output
response.
module. And last one is the
Problem
CP.
solved.
This is a communication
Grammarly can make
module.
all the
CP
difference
is
in
a
your professional
communication
success.
module. This is a
Click the blue
Profibus
button to
communication
download
module.
Grammarly today.
This hardware we will add in the schematic manager. Before I start the software, I will tell you one more thing. the coding of the module tag. This is the one tag, and by tag you can know this is the input module, this is the analog module, this is the CPU.
Hello
by
friends,
tag
today our topic
coding.
is S7.
This is the code of the one tag
hardware
and
how to
6,
add this hardware in Semantic Manager
This is
software.
the main, this is the step 7
And you
PLC.
can see
in the screen this
300,
is the 3. This is
S7
the
300 PLC
S7
hardware.
300
First
PLC
one is the
model.
Okay,
PS,
this is
PS means
3
the
showing
power supply.
S7 300
And
PLC
second one
model.
is the CPU.
And 2 more digits will be
And
here.
third one is the
Okay,
IM.
is
Is
the
the
interface module.
If
If
you
you
start
want to
from one,
interface
it
your
will show
PLC
to
to
other PLC.
If it
you
is
have to
start
use this
from 2
interface
and
module.
to 1, it
And
means this the input
this one is the
digital
DI.
module.
This is a digital
If
input
double
module.
2, it means
And
this
this one is
output
the
digital module.
digital
And
output
same
module.
way
DO
one will show
and this is the
input analog module.
AI analog
3
input
to
module.
show output
And
analog module.
second last is the AO.
Double
This is the
3,
analog
3, 4
output
it
module.
will show
And
input
last one is
and
the
output
CP.
analog
This is the
module.
communication module. C
And
is the
double 5 is the
communication module.
control
This is the
module
Profibus
like
communication module.
temperature.
Okay.
Okay. This hardware
So
we will add
any
in the
value
Semantic
of
Manager.
this
Before I
two
start the
digits will show
software,
the
I will tell you
module
one more
type.
thing.
Okay, and last one is the in
The
green
coding
color
of
is the
the
model number of the module
tag.
So very important thing
This is the
in
one
this
tag, 2 digits.
And by tag
By
you
2
can know
digits
this
you
is
can
the input
know
module,
about
this is the PLC
analog module, this is the
type.
CPU,
Is
by
CPU
tag,
input module, output
coding.
module, analog
This is
module.
the code of the one
and
tag.
control module
And 6,
communication
7
module by these
sorry,
two
6 ES7.
digits. This is the main
Okay.
is the step
Let's
7
start
PLC.
the software
3. This is the S7 300
Semantic Manager.
PLC
This is the
model. Okay, this is
7 300
is showing S7 300
PLC
PLC model, and 2 more digits will be here. Okay,
And
if
finish
one
this,
it will start from 1, it will show CPU.
and
If
start
it
this
is
new
start from 2
file
and
file.
to 1, it means this is the input
Name is
digital module.
hardware.
If double 2, it means this is the output
How
digital
to add
module. And same way 3 1 will
hardware.
show input
This is our
analog
topic
module
number name.
3 2 show output analog module.
Okay.
Double 3 3 4 it will show input and
No.
output analog module.
Click,
And
right
double
click
5
on
is
it
the control
and
module
insert
like
new
temperature. Okay,
And go to
so
your
any
schematic
value of
300
the
station. This is your PLC.
this 2 digit will
and
show the
it will show there.
module type.
And again
Okay,
click
and last
on
one
it
is the
and open
in green color
object.
is the model number of the module. So very important thing in this 2 digits. By 2 digits you can know
And you
about
can
the
see
PLC
at this
module
point you can
type.
add your
The CPU input
hardware.
module, output module,
First
analog
goes to the,
module,
Semantic
and it control
300.
module, communication module. By these
and
two
go to rack
digits. Okay,
and
let's start the
click
software.
the rack.
It will show the
Rack. Okay.
Semantic Manager.
So
This
we
is
will
the
start the I will
7300
delete this one.
PLC
first
one is the
software.
our PS. This is the power supply.
So
And finish this. We will add the power supply in it. PS and start
can
with
see new
PS300 file, and you can select your
Name is
power supply as your
hardware.
like 2 ampere, 10 ampere, 10
How to
amperes,
add
2 ampere, S07. Okay, so
hardware.
my I will
This is
select
our topic
PS
number name.
305 2 ampere,
Okay.
and will be add in first.
No.
You can add total
Click,
11
right click on
module
it
in this rack and insert
and
new
first
subject.
position
Position is for
and go
power
to your
supply.
schematic
And
and
second is
300
for
station.
CPU.
This is your PLC.
And go to CPU
and
it will show there.
you can see
3
and
1
again
every
click on it
CPU has
and
a
open
value of
object.
1 2 1 2 1 3. Okay, as I told you in my lecture in the
And
start.
you can see
at this
so
point you can
our
add your CPU
hardware.
is first goes to the Semantic 300 3 1
2
and go to rack and add this 2.
click the rack.
Okay, it will show the rack. Okay,
You can see you
so we will
also
start the
check the 6
I will delete this one. Sorry, 6 ES7.
first one is the our
305.
PS.
This is
Power
the
supply.
power supply.
And 312. This is the
So
CPU model number.
we will add the power
and
supply in
this
it.
is the version number 2.
PS.
Okay.
You can see PS.
And next one
300.
is
and you can select your power supply
IM,
as your
interface
hardware.
module.
This is
Like
the 2 ampere, 10 ampere, 10 ampere,
fixed
2
position
ampere,
for
S07. Okay, so my
interface module.
I will select
PS
PS position is the fixed for
interface
305 2 ampere
and
close this one and will be add
and go
in
to
first. IM. This is IM. You
interface
can
module.
add total
And I will
11
select
module
IM
in this rack.
360 IM
And
as
first position is for
okay.
power supply, and second position for CPU. And go to
So
CPU. And you
sorry,
can see
okay, I will
3
use
1.
this one.
Every
And
CPU
we'll
has a value
then
of
3. Okay.
1 2 1 2 1 3. Okay,
Now,
as I next one is told you in my lecture in the start, DI digital input. So our
and I will go
CPU
here.
is 312 and go to SM and add 302 and
Okay.
DI digital input. You can
All
see
the
also
digital input
has a
check
321
code.
Sorry, 321 code is a 7, digital
305
input
is the
power supply, and 312 this is the CPU model number and is the version number 2. So select your module according
next
your
one is-
hardware. So I will select this one IM interface module. This is
drag
a
here.
fixed position for interface
Okay.
module. 3 position is a fixed for interface module. Next one is and digital output. Close this one. So and
I
go
will
to select IM. This is
DO.
IM interface module, and I will
my
select IM
hardware
360 IM as this one. I will add this is the digital. So I output. Sorry, okay. I will use this one. And next one is the analog
N3.
input. Okay. Now
So
I will go. Next one is DI analog input and select DI digital
Every
input. Analog input
and
has
I
a
will go
port
here.
33331. Okay, and pick and drag here and go to SM. Okay, 300. And next one is
And
analog output DI digital input. So
all
I
the
will
digital
input
click
has a
on
321
AO
code.
300.
321 code is a
and this is
digital
the
input
input.
module.
Okay.
And last one is communication module. So
CP.
select your module according your hardware. So I will select this one and drag here. Go to CP. This is a communication module. Okay, and like I want to Profibus because in next one is
Profibus.
digital output. So I will select it. So
Profibus.
I will select DO and drag here, and my hardware has. So this way you can add your hardware. I will add this is a digital. Okay.
Output.
So same as a picture, I add the all the module in our. And next one is the
PLC.
analog input. And go to save and compile. I will go. AI is the save input and select compile. So you can see
Every
for
analog input
dressing
has a
you
code
can this is
3
the
double
digital
3
input
1.
dressing from
Okay.
0 to 1 like
And
0.1 0.2
drag
0.3 0.7 and 1. Okay, and digital output
And
has
next
a analog output like this is a digital output. This is a
So
dressing
I
from
will
4 to 5
click
4 like
on
4.01
300.
4.0
and this is the
2
no.
and will be on 5. And last
And
one
this
is
is
the analog input communication module CP dressing, and this is the analog output dressing, and this is the your communication module dressing. So by using this table
CP, this is
and
the
you can
communication module.
program
And
your
I want to
PLC by
Profibus
using this dressing of
because
input and
in our
output
module
and
the Profibus.
analog. And
So I will select it Profibus.
communication module. If you have any question regarding this
And
lecture,
drag here.
you can raise a question.
Okay.
So this way you can add your hardware. Okay.
Hello friend.
So same
this lecture,
as a
I will
picture,
tell
I
you
add the
how
all
to
the
use
module
simulation
in
of
our
Semantic
PLC
Manager
and go
Siemens
to
S700 PLC.
save and compile.
So let's start the
Okay, it's
software.
a save and
Go to Semantic
compile.
Manager S7.
So you can see for dressing,
And
you can this
as
is a
in
digital
our
input
previous
dressing
lecture,
from
lecture
0
number
to
2,
1
I
like
have
0
told you
0.1,
how
0
to add
0.2,
the
0
hardware
0.3,
in
0
the
0.7 and
software,
1.
Semantic Manager
And
software.
digital
So
output
we will
has
open our
a
previous lecture.
like this is a digital output.
Go
This
to
is a
open,
dressing
and
from
this is
4
how
to
to
5.
add.
4
This is
like
lecture number
4.01, 4.02 and will be on 5. And this is the analog input dressing, and this is the analog output dressing, and this is your communication module dressing. So by using this table, you can program your PLC by using this tracing of input and output and analog and communication module. If you have any question regarding this lecture, you can raise a question.
Hello friends, in this lecture I will tell you how to use simulation of Schematic Manager for Siemens S7300 PLC. So let's start the software. Go to Schematic Manager S7, and as in our previous lecture, lecture number 2, I have told you how to add the hardware in the software, Schematic Manager software. So we will open our previous lecture. Go to open, and this is our how to add. This is lecture number 2. And open it. Okay, and you can see this is the hardware. This hardware we had added in our previous lecture, lecture number 2. So in this lecture I will do some programming and tell you how to use simulation of the software, Schematic Manager. So go to back, and this is a CPU 312, and go to source and block, and go to OB1. And in this block you have to tell about the language, programming language. We will use ladder diagram, LAD, and go to OK. So this is one window for programming. So for start of the initial inputs output, we have to use this table. You can see for our digital input is from 0 to 1. So we will use one input, and output addresses is 4 to 5, like 4.0, 4.1. So 4 to 5, this is the addresses of the output, and 0 to 1 is the addresses of the input. So we will add one input, and I will add I for input as 0.1. This is a one input and one output. Q is stand for output, and 4.0. This is our one output. Okay, I made one wrong program, one input and one output. So now we'll start the how to we use this in simulation, how to we on off the input output for checking the our program. So go to back and go to this simulation on and off. Okay, this is a PLC sim 1. Okay, you can off this one, and I will tell you how to add this one. You can, this is a input block, insert input, output, memory, timer, counter. This is a simulation platform. Okay, so before start of the simulation, you have to go back and go to the programming and download this one. And this is the error, and unable to reach the module CPU 312 via online interface. You have to go to the setting of the interface of the PG. So go to Schematic Manager and go to option and set PG and PC interface. In this option I will select PLC SIM MP1. Okay, and press OK, and download this one.
Yes. And now go to same PLC sim MP1 must be here. Okay. And now you have to go to here and press. Now your program is downloaded. Okay, no error. And now go to simulation. Okay, now you have to run your CPU. Okay, now our input is I01. So this is our IB0 block, and this one is our input. When I press it is input, and you can see in the program this is the output is 4.0. So I have to select here 4. Okay, now when I will on my input, you can see this output is on. Okay, when I off input, output will be off. Okay, this way you can check your program. And more over there, you can also check the ladder diagram. Press monitoring, and you can see this is a run mode. Your PLC is in run mode, and this time your input is off and output also off. So I will go to the PLC sim 1, and I will on my input, and you can see your output is on. Okay, so same way, if you off my input, your output is off. So this way you can use simulation of the software, and you can check the program by using PLC sim, and you can check your ladder diagram, your logics without hardware PLC. Okay, if you have any question regarding this lecture, you can raise the question on the comment box. Our team will be give the answer on your question. Okay, bye. Hello friends, today is very important lecture of the Siemens PLC. In this lecture we will cover the basic tool of the PLC programming, bit logics. You can see this is the bit logic, and first one is normally open contact. You know well about this one. This is the same like other PLC, and this is a normally closed contact. So this is a one invert power flow. So we will start from this one, invert power flow. Actually this command will change your logic from yes to no, no to yes, 1 to 0, 0 to no, 0 to 1. So we will do practical, and this one is the invert power flow. Okay, this is a command. So we will take one input, and let I 0.1, and one is output. Q 4.0. Okay, so I will use this command. This is the invert power flow. I will drag here, and you can see this is a symbol of the invert power flow. So I will download this one in PLC and go to simulation and run your PLC and go to your monitoring. Okay, and you can see this one, your input is off but your output is on, because this invert flow change your logic from 0 to 1. When I on this input, So this is a 1, so this is a 1. You can see when I on the input but your output is off due to this invert power flow. This is a invert logic. If your logic is on but your output is off. Okay. And next one is coil, is the same like other PLC programming, and this one is the midline output. You can see this in this rung you can use only one output. You cannot use the other output on same rung. You can see here, but by using midline output you can use two output in one rung. Let's start. We will insert, and this is the midline output. Okay, and you can see one input, and I will use I 0.0 0. And one output same Q 4.1. okay, and use branch, use one more output Q 4.2. This is a one way to use two output by one input. Okay, and I will insert one more, and this is the same midline output and same logic. I 0.2 is the one input and one output Q 4.1. okay, so I will use one more output here same rung by using midline output. Okay, and use same Q 4.2. okay, and download the program and go to monitoring and on the your PLC, run the PLC. Okay, now you can see here this time your I 0.01 is off, and I will on this one, your both output is on. Okay, now I will on this input 0.2, and you can same way to output is on. So by using midline output you can close your complex programming into very simple way. In this we are using two rungs branches for on to two outputs. So by using midline output I can on the two output by input in same rung. Okay, so of your PLC of the monitoring. Okay, next one is set and reset. Is the same like other PLC. I will give the one demo. I insert one more input network, and I will use one input I 0.3.
use some one output. For this rung, use set Q 4.5, and I will add one more, insert network, and one input I 0.4, and use the reset coil Q 4.5, same. Okay, and download the program, and metering is on your run your PLC. No, I will close all input. No, this one is the I03. When I on the I03 0.3, and you can see your output is set. When I close this one, automatic your input is off, but your output is set. You can see this a green line. Okay, for reset this output, you have to on I 0.4 input. So I will on this one, and you can see no, this is a not set, this is a no reset. So this way you can reset the your output by using set reset command coil. Stop the PLC and stop the metering. Now next one is the flip flop. This is a reset flip flop, and this is a set flip flop. So first we start the set reset flip flop. I will add one more network and use set flip flop. Okay, and use any memory like M0.0. Okay, sorry, 0.0. Okay, and one input like I 0.0. And in R use one more input .1 or one output Q 4.0. Okay, flip flop same like set and reset command, but it has some priorities. Okay, so I will show in logic, and download the program, start the metering, and start your PLC in run mode. Okay, when I on the input, and you can see your output is set, and I off the input I 0.01, your output is still in set. Okay, and when I on the reset 0.1, and you can see your output it reset, same like set and reset command. But when I on the input I 0.0 and I 0.1, and you can see the purity is reset, your output is reset, even your input set and reset both is on. You can see I 0.0 and I 0.1, both is on, but your output is reset because this flip flop is because your set reset flip flop, its purity has reset. When I off the reset, again your output is set. Okay, so this way this is a flip flop. And use other one, I add one insert and same like one input and one flip flop. No, I will take reset set flip flop. This is the other one. You can use the SR, this is the RS. So input is I 0.0, this is the reset, and I 0.1. I use M 0.1 and output Q 4.1. Okay, you can see the difference between SR RS. In this block, S is in first and R is last, but in case R is first and S is last. Okay, so this is a reset set flip flop and this is a set reset flip flop, and you can see the difference between both. I will do practical. I stop the PLC and now I download the program on the and go to the and now run the PLC. No, you can see this time you can see your both output is off, sorry, input is off. When I on the I 0.0, your program, your Q 4.0 is set, but in this case it is a reset because its purity is reset. Okay, so when I on the both inputs, and you can say its purity is set because both inputs on, but RS on the output, but this is the off the output. This purity is reset and this purity is reset when your both input is on. Okay, this way you can use flip flop. And next is the positive edge and this is the negative edge. So in the same way other PLCs, I will insert and one input I 0.0 and Q 4.0 and use P positive RLO edge detection. Select this one and add this one. Okay, so I will use here set, it will give you more clearance concept. I use Q 4.0. Use one more insert input
I 0.1 and same set, like use one reset. Q 4.0 same output but use negative RLO edge detection and give any like M0 and same M0.1. Okay, now I will stop the PLC and download the program and start the monitoring. Now on the PLC, and you can see this time your both input is on. So no start. When I on the input I 0.0, okay, your output is set because this is a positive edge. Okay, now I want to reset this coil. So this is a negative. When I move this input from 1 to 0, then your coil will be reset. You can check. You can see I on the input from 0 to 1, your coil still on, is a set, you can see. Okay, it is still set, but I off the input I 0.1 from 1 to 0, then it automatically reset. This green show is a set, and when I move from 1 to 0, it is reset. So this is a positive and negative like other PLC. So same way you can use this one, is the same work like this P and N. This is the address negative edge detection and this is the address positive edge detection, but in this case you will use a block. I give the example. I stop the monitoring and off the PLC, stop the PLC and add the one inserted run, and when I add the same like this one, but it is in block form. Okay, for any question in this lecture you can raise the question in comment box. Our team will be give the answer of your question. Okay, bye.
Hello friends, today our topic is timer. In this lecture we will study how to use timer in S7-300 Siemens PLC Schematic Manager software. Let's start. There are 5 type timer we can program in S7-300 PLC Schematic Manager software. You can see on the screen there are 5 types, and first one is pulse timer. Its short form is S pulse timer, and second one is the extended pulse timer, and its short form is S PEXT, PEXT timer, and third one is on delay timer, and its short form is SODT, on delay timer, and fourth one is retentive on delay timer, SODTS, and last one is the off delay timer. First 2 timer are pulse timer, and third one is on delay, fourth one is also on delay timer but is retentive, and last one is the off delay timer as same other PLC. And you can see this is the symbol of the timer in Schematic Manager software, and this is a timer number. You will write here timer number like timer type T0, T1, T2, T3, and this is the timer type. As you see, these are 5 types, and according your project and logic you will use according your requirement timer type. S. S is fast set. This is the input signal. S is the set signal of the timer. TV. And TV is the storage value. Your required value will be here. And you can see here, you can enter maximum 9990 seconds. It will equal to 2 hours 46 minutes and 30 seconds. R is for reset the signal of the timer. If you want to reset the timer, you will use R command here. Q is output of the timer, and BI is the current value of the timer in binary code, and BCD, this is the current time value in binary coded decimal code. Okay, and timer number you can see this is a timer number T, and you can the range from 0 to 255. Total maximum 256 timer in S7300 PLC. And you can see this is how to write the timing in the timer is S5 time / your required time, like 4S equal to 4 seconds. This is the syntax to write the time in timer. Okay, let's start the on software.